Hi friends, welcome to the Unit 6 Day 3 notes. Today we're going to talk about the converse of the Pythagorean theorem. A lot of students remember the Pythagorean theorem. That's the a squared plus b squared equals c squared. This one talks about if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Then the triangle is a right triangle. And this is actually kind of going backwards from where you probably remembered it from middle school or elementary school, where we say if c squared is equal to a squared plus b squared. So we're starting at the longest side. So remember, that's the longest side. That's your c. C is across from what we think might be the right angle. So then we have triangle ABC is a right triangle. I don't know why I put a floating period there. There we go. All right, so example 1, tell whether the given triangle is a right triangle. So here we're going to actually test to see if c squared is equal to a squared plus b squared. And the way we do that is we plug in or substitute those numbers into each of these values in the variable. So this is going to be 3 square root of 34 squared equals. Now for a squared and b squared, it doesn't matter which one you pick. You just have to use the other number on the other side. So here, 9 squared plus 15. Now, 15 squared. Whenever you substitute a number, make sure you put it in parentheses. That's always when you substitute a number, you put it in parentheses. So for here, we're going to take 3 square root of 34 squared. Notice I didn't, even try to simplify square root of 34. I just left it as that. And the reason why is because when we take a number, for example, 3 square root of 34 squared, we take both this part, so the coefficient 3 squared, and the radical square root of 34 squared. And then I'm going to go ahead and just grab my calculator and do these other ones. So here I've got 9 squared is 81, and then the squared key, in case you forgot, remember the square key is right there. And then we're going to be using, I'm going to show you the square root here in a second. 15 squared, 225, or you just remember those because we've been talking about these perfect squares a lot this unit. Remember, square root and square, they undo each other. So if I take the square root of 34, close parentheses, and then square it, I should get back to 34, and I do. And that's just part of what's going on here with the opposite or inverse operation. So 3 squared, that's 9. So I have 9 times 34 equals 81 plus 225. I do not know that off the top of my head. 306. Then 9 times 34 is also 306. Oh, there is a glare. There we go. That's also 306. So I have 306 equals 306. Is that a true statement? Absolutely. So because that's a true statement, then this is a right triangle. This is a right triangle. Now, for this one over here, we're going to be testing it out as well. Remember, the c squared is the longest side. So out of all of these numbers, I put the largest or longest side in for c. So that's going to be 26. So 26 squared equals 14 squared plus 22 squared. Now, using parentheses on these, it doesn't actually affect anything in the problem because we're just taking that number squared. It would on this problem here, so that's why I always make sure that I include parentheses when I go through in each part. 26 squared is 676. 14 squared, I forgot, 196. And then 22 squared is 484. So then I just add 484 plus 196. I get 680. So I'm saying 676 equals 680. So that's not true. So I put an X to show that that's false. This is not a right triangle. So not a right triangle. So there's example 1, verifying that it is a right triangle or not. We can classify a triangle by its angles. Remember that a right triangle is a triangle with a 90-degree angle. Triangle with one 90-degree angle. We have an acute triangle. That's triangle with all three sides, or all three angles, all three acute angles. Remember, acute is less than 90. Acute angles. And then an obtuse triangle is a triangle with an obtuse angle. So here, this part where it has that blank, so the other types of triangles that we can have besides the right, acute, obtuse, we talk about a triangle that has all the same side lengths, all the same sides. So for that, I'm just going to kind of leave this blank. If you look on the notes for this actually isn't filled out. This part, for this, we were talking about different types of situations where all three side lengths are the same. And we talked about that in a previous unit. When we have a situation like this, then we know that this is an equilateral, an equal angular triangle. We were talking about that when we talked about perfect polygons, so that's where that came from. We don't actually use that in the rest of these notes, so we kind of ditched that. So don't worry about that for this part. So now we have a situation where, well, what about like up here where we had it where one side was less than the other side or one side was greater than the other side? So here in this situation, if the square, the sum of the longest side, if it's less than both of those, then what we have is a situation where we have a triangle that's acute. So in this case, the triangle is acute. So then we would say the triangle is acute. So if it's less than, notice that we're being really specific on the order here. So we're doing the c squared part. The c squared part goes first, and then we add in the sum of the other two sides. So this is where it's really important to note the order. Order on this is super important. So we're doing what we know to be the longest side, C, the longest side, first. So keep that in mind as we go through this. And then greater than, so if now this side is greater than the sum of the other two, then the triangle is obtuse. And this idea is actually used in construction all the time because you want right angles a lot in construction. If you look around the room that you're in right now, you'll probably notice there are a lot of right angles in the construction of the building or the room that you're in. And it's really important that we keep that. And that way, whatever we're in doesn't fall down. The triangle inequality theorem talks about the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So what that means is that if I take 3 plus 4, that has to be greater than 6 for this to be a triangle. So this has to be true for it to actually have a triangle. So this could be a triangle. So this one, 3 plus 4 equals, 3 plus 4 is greater than 9. Well, that's false because 7 isn't greater than 9. So this is not a triangle. Couldn't be a triangle. This can be a triangle. I'm going to use the symbol for my abbreviation for triangle. This one, 3 plus 4 is greater than 7. 7 is greater than 7. So for this one, is this 7 is 7 greater than 7? So it's not, so this is not a triangle. Then this one, 3 plus 3 is greater than 3, 6 is greater than 3, yes. This is a triangle. And I actually know this is a triangle because all the same sides are, all the lengths of the sides are the same. That's actually looking at what we talked about on the previous page where it's the equilateral triangle. So here, for example, 2, what we're trying to do is see, okay, first, is it a triangle? So we're just checking that first. Is it a triangle? And then if it is, see if it's right, acute, or obtuse. So checking first, I need to check the smallest 2, add them up, and see if it's greater than the one that's left. So 5 plus 12, that needs to be greater than 13. So is 17 greater than 13? Yes. that means that this is a triangle. We need to test it out to see what type of triangle it is. So what we're going to do is we're going to do the c squared. And then I usually put a box here because I don't know what sign to put in there. I don't know if it's going to be greater than, I don't know if it's going to be less than, I don't know if it's going to be equal to. So that's what we're going to find out. So switching colors, c squared is the length of the longest side, so that's going to be 13. A, I'll say, is 5, and then B is 12. All right, 13 squared, 169, 25, and then 144. Then if I add those two up, I get 169 and 169. And then that is equal to each other. So because it's equal to, then I know that it's a right triangle. So this one is a right triangle for number 4. I'm just going to check square root of 8 in my calculator. Instead of going through and simplifying for each part, I'm just going to do square root of 8 plus 4, and that gave me 6.828427125, and that goes on forever because it's an irrational number. That means that it is greater than, square root of 8 plus 4 is greater than 6. That's true, so I can verify. Now I can keep going and actually find what type of triangle it is. So the length of my longest side, in this case, I already did square root of 8. I know that it's 2.8 something. It's helpful to do that to see which side length's the longest as you're going through, because maybe this number, even though it's listed first, maybe it is actually the longest side. So you want to check that as you go through. So this is going to be 6. And then I don't know what that is. So let's do 4 squared for here, and then square root of 8 squared for here. Okay. Parentheses, okay. 6 squared is 36, and then 16 plus 8. So 36, and then the relationship here, 24. 36 is greater than 24, so then I know that this is an obtuse triangle. And then now for this number 5, I know 20 plus 21 is greater than 28. So I know that that's going to work, and now I can test it. A squared plus b squared. So now I can substitute or plug in. So c squared is going to be 28 squared. Put my parentheses first. That way I don't keep running into my squared. Plus, and then 21 squared. Okay. Don't know 28 squared off the top of my head. 784, okay. And then, I know 20 squared, 400. Don't know 21 squared. 441. So 784, and then 841. So that's less than. So because 784 is less than that, I know that this is an acute triangle. Go ahead and pause the video, try these last 3 on your own, see if you can get it. Take a moment, see if you can figure it out, and then we will continue on through the last 3 here shortly. All right, did you finish it? Did you pause? Did you? I'm asking, did you? Okay, all right. So we've got testing first, 15 plus 36. I know that that's greater than 39. Notice that I'm testing this each time because we might get a situation, say on the worksheet, where it doesn't work and you need to make sure you do that. So we know that that's true. So now we can check c squared and then a squared plus b squared. So c squared is 39. Oh, I did it again. Gotta put those parentheses in. Come on, Brumman. You got this. And then 36 squared. Perfect. All right. So then I can do 39 squared. 1,521. Ooh, big numbers. 15 squared. Oh, I knew this. 225. 36. Oh no, 36 squared. Big numbers again. 1296. So now if I add these together, plus 225, I get 1,521. Oh, sweet, they're equal to. So because they're equal to, I know that it's a right triangle. right triangle. Perfect. Square root of 13, again, square root of 13. Oh my goodness. Square root of 13, there we go, is about 3.6. So if I add that to 10, it is greater than 12. So again, verifying each time that it does work. And then c squared, some relationship with a squared plus b squared. So now we got, let's see, so 12 will go here for the c. Then it doesn't matter what I put for my others. So I'll do square root of 13 and then 10 squared here. So 12 squared is going to give me 144. And then square root of 13 squared is 13. Then 10 squared is 100. So then this gives me 144 is greater than 113. So that means that this is an obtuse triangle because it's greater than. Then here for number 8, 14 plus 48 is greater than, plus 48 is greater than 50. So this does work, so now I can check. So I'm going to have c squared and a squared plus b squared. So my longest side is 50, so 50 squared, some relationship with 14 squared and then 48 squared. So 50 squared, 2,500, 14 squared, I knew this, 196, plus 48 squared, 2,304. If I add that to 196, hey, I get 2,500. And 2,500 is equal to 2,500, so this is a right triangle. Down here at the bottom, this is just a quick kind of overview on the different things that we just talked about. There's actually a missing symbol here, here, and here. So pause the video, see if you can answer it, and then when you restart, I will go through and just quickly say what each of these are. Perfect, thank you. So this here is equal to, because we have the measure of angle C being a right angle, because it's equal to, and the triangle is a right triangle. So for this one, c squared is less than that, because the measure of angle C is less than 90 degrees. And this, c squared is greater, and the measure of angle C is greater than 90 degrees. So you can kind of think about, you're looking at the measure of angle C in this when you think about it like picturally or visually, and that's what's making it become that less than value or greater than value, depending on how you go through and set it up to solve. I hope you have a wonderful day. I will see you soon. Bye, friends.